Hi, this is Ms. Elkins. I'm here to teach you some basic trigonometric identities and how to apply them. So this is the first video. In fact, I'm going to write that on here. We'll just call this number one because I'll have a couple more. All right, let's get started. The the identities that you need to know are listed here. You should go ahead and jot them down if you don't have them written down somewhere else. So go ahead and pause the video to do that, and we'll go over them. Um, The, the two quotient identities may be somewhat new to you. You probably did not have them in geometry. The reciprocal identities, I think you should be very familiar with these already. And there's actually 6 of them. I'm just listing the 3 because they're kind of interchangeable. The cosecant of theta is equal to 1 over the sine of theta. Could also be stated as the sine of theta is equal to 1 over the cosecant. So it's kind of a matter of you knowing which ones are reciprocals of each other. Okay, and I could do that here and here also. But the important thing to notice on the quotient and the reciprocal is that, of course, your denominators cannot be 0. And instead of writing that for each particular one, I'm going to just say that denominator not equal to 0. Okay. On the Pythagorean, these all come from the unit circle, and you just need to, we're going to use those today, so make sure you have those written down. And of course we have 3 of those. All right, so there's 6 plus 3, that's 9, and 2 more. There's really 11 that we're going to be using, but only 5 of them I think are going to be somewhat new to you. All right, let's get started. What we're going to do is we're going to prove a statement is true by transforming one side of it until it matches the other side exactly. And I've kind of set them up so that we'll be working with the left-hand side, and we're going to work vertically by applying the identities. So let's start with this first one. I want to prove that the tangent of theta times the cosecant of theta is equal to the secant of theta. So what I'm going to do is I'm just going to change, I'm going to take my tangent, I'm going to make it the sine over the cosine. I'm going to try to remember to always include my theta here. All right. So I'm changing the tangent, and I'm going to go ahead and change the cosecant too to 1 over sine. Alrighty. And what happens, as you can see, I'm multiplying 2 fractions where I can cancel out the top and the bottom, and now I have 1 over cosine. All right, which doesn't exactly match, except that by the reciprocal identity, 1 over cosine is the same as a secant. And then we are done. Okay. There you go. We are done. These 2 match. So we finished this first one. Okay, let's go ahead and work on number 2. So the entire left-hand side has got to be equal to the right-hand side. Cosecant of theta times sine of theta minus sine squared of theta. And I'm going to go ahead and take my cosecant, and I'm going to change it to its reciprocal, 1 over sine. And let's take a look at the sine. I'm going to go ahead and leave sine the way it is. Oh, look at that. Interesting. Howdy, I'm seeing a little situation here. So what happens when I multiply 1 over sine times sine, is really 1 over sine times sine over 1, I get sine over sine, which is the same as 1. So all of this is now equal to 1. All right? So 1 minus sine squared. Okay? Well, this doesn't exactly match the Pythagorean identity, but it's pretty close. If you take a look at the one involving sine and cosine, it says sine squared plus your cosine squared is theta is equal to 1. And what I can do is I can go ahead and subtract the sine squared from both sides, and I get cosine squared equals 1 minus sine squared. Okay, so just, and if I change around the Pythagorean identity, I now know that this right here is the same as cosine. So basically, 1 minus sine squared is my cosine. And I noticed that when I originally wrote the problem down, I wrote it down wrong. So really, we did it correctly. It's just that the original problem was written written wrong. I'm going to fix it right now. Instead of cotangent, it's supposed to say cosine. There we go. It's nice how I can make my answers work like that. There we go. Okay. Alrighty. And um, and actually I forgot a square too. I forgot that. Okay. Alright, so this is what the original problem did say cosine squared. Alrighty. Let's go ahead and move on to the next one. Number 3. Sine theta times cosecant theta divided by the tangent of theta equals cotangent of theta. Before we move on, I'm going to just take a quick look and make sure I wrote it down right. Yep, I did write it down right. Okay, so I'm going to start by changing my cosecant. So I'm going to rewrite sine of theta, only instead of cosecant, I'm going to call that 1 over sine by the reciprocal identity. Okay, and that's still all over tangent. Okay, and again, when I do sine times 1 over sine, I get sine over sine, which is the same as 1. So all of this right here becomes just a 1, and we get 1 over tangent. All right, and 1 over tangent by the reciprocal identities is cotangent. Okay, and since these two match, I'm done with that problem. Okay, now let's take a look at number 4. I'm going to go nice and slow with this one because this is a little more challenging. And this is also supposed to be equal to sine. Okay. So the very first thing that I'm going to do is I'm going to write this fraction out as division, just to get me started. And I'm going to start by, well, I'll just kind of write the whole thing out. Secant theta divided by cotangent theta plus tan theta, right? And now I'm going to do a little substituting. I'm going to take my secant and I'm going to turn it into 1 over cosine because of the reciprocal. All right. And then I'm going to go ahead and I think I'm trying to see if I'll do it in 2 steps. I'm going to change this back to division. Okay. I'm going to take my cotangent. I'm going to make it cosine over sine. Okay. I'm going to take my tangent. I'm going to make it sine over cosine. Okay. Now, you notice that since I'm dividing by all of this, what I can go ahead and do is, let's turn this into one big fraction and put a 1 on top of it and make it multiplication. So let me rewrite all this. It's going to be 1 over cosine times all of this. I should probably not put a 1 yet over there, but there we go. Cosine over sine plus sine and cosine, okay? And what happens is I'm going to go ahead and I'm going to multiply straight across, like you normally do with a fraction. Multiply straight across. The numerator times numerator, denominator times denominator. What will happen, of course, is I'm going to end up with a 1 on top, 1 times 1. But on the bottom, I'm going to end up with cosine times cosine over sine. Well, that's cosine squared over sine. And then when I do cosine times sine over cosine, well, I'm going to get just sine, because the 2 cosines will cancel out. All right. Now what I'd like to do is, what I'd like to do is take this new expression, and I want to create a common denominator for the denominator. But what I'm going to do is I'm going to take my sine, and I'm going to multiply it by sine over sine, so that I can add these two together. So what I'm doing is I'm going to turn this into sine squared over sine. together, cosine squared, cosine. So now I've created a situation where I have common denominator and I can kind of restate this. I'm going to kind of running out of room, so I'm going to rewrite this over here. So now I've got my cosine squared plus my sine squared all over sine. Okay, now, I'm going to go ahead and substitute. It does double check here, but it's there. Perfect. Let me put the one over there. So what I can go ahead and do is just 1 over all of this divided by sine, and is equal to this. So what I'm going to go ahead and do is rewrite it again. And I am basically taking 1 and dividing it by the cosine squared, or sine squared, all over sine squared. Now remember, I can go ahead and substitute a 1 for that. Okay? It's because of the Pythagorean identity, cosine squared plus sine squared equals 1. And then I've got 1 divided by 1 over sine. So if I'm going to divide something by a fraction, I can also multiply it by its reciprocal. So I'm going to multiply by sine over 1. So 1 times sine over 1, well, what is it sine? And they're kind of very messy, but I'll clean that up and repost it. But basically, this is what I wanted. I wanted to have sine because I had sine up here. So you can review that and look for another video.